Hi grade 9s, we are on the Unit 3 Day 5 lesson, and in today's examples we're going to be looking at the same kinds of equation solving that you've been doing in previous days' work, but now it's all going to be really focused on using equations to solve applications or word problems. So before we get started, I want you guys to take a look at the warm-up. There are three equations in your note for a warm-up. So pause this video if you have not done the warm-up yet. Pause this, try them on your own, and then watch the solutions, check your answers to be really sure and confident that you yourself understand how to do these independently but without help from the video before you keep watching. So if you've completed the warm-up on your own, check this work. In the first one, pretty straightforward. It is, sometimes people get a little bit mixed up with the signs here when the x and the number are written in a different order than normal. But we get negative 2x equals 14 minus 4, negative 2x is 10, and dividing out we get x equals negative 5. The second example here, I have fractions, so I've written my 25 as 25 over 1, and multiplying through by the lowest common denominator, which is 12. I've reduced out where I could, and I wrote this out just for clarity, but you don't actually need to write this line if you can very, very carefully and multiply these and your work hasn't gotten too messy. So when I multiply out, I get 4w plus 9 equals 300. And bringing the 9 to the other side, we subtract and then divide by 4. Remember, we're not going to put that into our calculator and make it a decimal unless it's a word problem. If it's just a number like that, in a regular solve for the variable question, you leave it as a fraction. The third example has another kind of common spot where you have to be careful with not making errors. You need to distribute before you subtract. A lot of people might see this 5 minus 3 and say, oh, that's 2, and just put a 2, but you're going out of order of bedness if you do that. So don't subtract yet. You have to multiply the 3 in here, and then we've got our subtraction at the end once we've multiplied that out. So 5 minus 3x minus 6 equals 2x plus 14, and then bringing things to the correct sides, negative 5x equals 15, and dividing out x equals negative 3. So the first application is a word problem about somebody doing deliveries to a recycling center. Her earnings were $23.90 on her first trip, and the earnings are based on the following. She pays, so this is her cost, she has to pay $8 per trip for gas, and she earns $72.50 per ton for the amount of paper she brings. So we are going to make an equation for her earnings. Whenever we have an equation, I'm going to say what my variables are. So I'm going to say E is her earnings, and we're measuring our paper in tons, so I'm going to put T, and this is the tons of paper. So how much paper she brings to the place to recycle. So the equation here that I would use is that her earnings, she's getting this much per ton, so she would get $72.50 times T, but then she'd have to subtract the cost of her gas, so it'll be minus 8. Now we want to solve this equation if we know her earnings for her first trip were $23.90. So if E equals $23.90, find T. So find the amount of paper she brought. So I'm going to use this equation. I'm going to say that $72.50 T, take away 8, she ended up making $23.90. So we're going to go through this and figure out how much paper she would have brought to the recycling place. So 72.50 T, a minus 8, we're going to add 8 to both sides. So plus 8 there. 72.50 T equals, that's going to be 31.90. And then we want to solve for t by dividing out that 72.50. Now remember, now we're working with word problems. So this is a time when you can put that into your calculator. So I'm going to do 3190 divided by 72.50. And I get t equals 0.44. So she brought about 0.44 tons of paper to the recycling to earn that much money. So therefore, she delivered 0.44 tons of paper. Okay, so again, in a word problem, you're always summarizing in a sentence and making sure you use units. So the next question, a photographer charges a sitting fee of $100. The first 4 prints are free. Each additional print costs $5.25. How many prints can you buy with $257.50? So if you want to get the pictures printed out, they'll print out 4 for free included with your $100. And any more above that costs this much money. Okay, so I'm going to use some variables. I'm going to say the cost is C, cost of the pictures. I might say N is the number of prints we pay for. So we're going to know that we would have the 4 free. But N is going to be the number of paid prints. So we know that C is the sitting fee of $100 plus $5.25 times how many prints we're paying for. So we know we want to figure out how many prints. So that means N is something we want to find. And C equals $257.50. So if C equals $257.50, N equals what we want to figure out. Okay. So here we're going to use our equation. We're going to put in our amount of money for the cost. If you paid that much money, how many pictures did you get? And now we're going to solve for our variable N. I might, normally I try and get the variable to the left, but there's only one and it's on the right. So I'm just going to do it the other way around this time. So I'm going to subtract 100 from both sides. And I'm left with 525N on the right. So 157.50 equals 525N. And then I'm going to divide by 525. And that gives me 30. So 30 is how many you paid for. So we're going to add, they got 4 prints for free. So therefore you can get 34 prints for $257.50. Okay. So again, there's different ways to approach this. It is really important that you say what each variable represents here. Some people may have done a different equation and included the 4 free by like subtracting or adding in your equation itself the cost of those prints. But we can solve it this way. Whatever the variables are that you're using, you have to do this for proper math communication. You have to tell me what those variables mean before you put them into an equation. Okay, last example in today's lesson. Tom has $10.95 in quarters and dimes. If he has 57 coins altogether, how much of each type does he have? So if we kind of think this through, if you were thinking about counting up some money, and you said, I've got a big pile of quarters and dimes, and altogether I have $10.95. If you were trying to figure out that $10.95, I'm just going to kind of say this in words here. Does it make sense that the quarters, you would say, how many quarters do I have? And then say 25 cents times that many. Like if you have 17 quarters, you would say 25 cents times 17. And that's how much money of quarters you have, right? So I'm going to say that the amount of money in quarters is 0.25 times number of quarters plus, and then we'd do the same for the dimes. If you had 32 dimes, you'd say 0.10, 10 cents times 32. How much money is that? So I'm going to do 0.10 times the number of dimes. We know that that equals $10.95. So that's just kind of a thinking it through. I would have 25 cents times how many quarters plus 10 cents times how many dimes, and that would give me this. Now we need to figure out a variable. So I might say n equals the number of quarters. So if n is how many quarters we have, I'm going to write this as 0.25 times n. If n is how many quarters, how many dimes would we have? If you knew how many quarters, what information could you use in the question to figure out how many dimes? Like if I said he has 23 quarters, how many dimes would he have? You know that he has 57 coins altogether. So however many quarters he has, you can subtract it from 57, and that's how many dimes. So I'm going to say 57 minus n. That's the number of dimes. Because if I had 23 quarters, you'd say 57 take away 23, you've got 34 dimes because they have to add up. So that's what I'm going to do. 57 minus n is how many dimes? So here 0.10 times 57 minus n now equals 10.95. And now this is an equation we can work with. We do have to be careful because here we've got a binomial. We have to distribute that in. So 0.25n plus, that's going to be 5.7 minus 0.10n is 10.95. And bringing this 5.7, subtract from both sides, 0.25n minus 0.10n equals 10.95 minus 570. Now subtracting here with the like terms, 0.25 minus 0.10, we get 0.15n. And then subtracting 10.95 minus 570 is 525. Now solving for n, we need to divide by 0.15. And we get n equals 35. So if he has 35 quarters, how many dimes does he have? 57 minus 35, which gives me 22. You should check this. when we have a word problem, we always want to check our answer. If I had 35 quarters, for my quarters, 0.25 times 35, how much money would that be? That's $8.75. And dimes, that's 10 cents times 22 dimes, that's $2.20. If you add these up, 8.75 plus 2.20 is 10.95. So my answer works out. These two numbers, 35 and 22, are 57 coins altogether, and they would give you 10.95 in the amount of money. So I would finish with a therefore statement. So therefore, Tom has 35 quarters and 22 dimes. Now I will say, for any of these questions on a test, you would need to do a full algebraic solution, and we would specify here and say create an equation and solve the equation to find how many coins he has, because we're trying to get you guys to interpret things into an equation. And if it was some kind of situation where you maybe could figure it out, because if you just sat there for half the test saying, okay, what if he had 1 quarter and 56 dimes? How much money is that? What if you had 2 quarters and 55 dimes? And you just kind of plugged away on your calculator, you could figure this out without any, just with trial and error, without any equation at all. But that would not give you full marks, because the point of these kinds of questions is to get you to think about how to write things into an equation and be able to solve that equation for all of the many times in math and in higher level science where you might you wouldn't be able to just kind of trial and error your way to a solution. So be prepared that you can't just look at these and do trial and error. You will not get full marks. That would probably be like a level 1 response if you just did trial and error. So make sure that you're working on these using the skills that we've done in this unit. So that's everything. We're going to look at some more examples of word problems in the day 6 lesson.